Ever get that, like, brain freeze when you see certain numbers? Like, maybe, a price tag that ends in .99 just seems so much better than a whole number.
Yeah, totally.
Well, get this. New research is saying something kind of similar might be going on in science, and it all comes down to that magic number, the p-value of .05.
Oh, the .05 p-value, yeah. It's a big deal. What's interesting here is we're not talking about just some random number, right? This is the p-value. This is like the gatekeeper, the bouncer of statistical significance. This is the thing that can make or break a whole scientific study, potentially.
Yeah. And today, that's what we're diving deep into, the psychology of that very p-value. Looking at some cutting-edge research from Vimal Rao and Jeffrey Bai of the University of Minnesota and Sashank Varma of Georgia Tech, published just this year. This is hot off the presses stuff that really makes you think twice about how scientists look at data, especially when that .05 threshold is staring them right in the face.
It's like there's like an invisible fence in their minds separating those eureka moments from those like back to the drawing board size.
Okay, so let's unpack this .05 thing. For those who maybe need a little refresher course, what exactly is a p-value and why do scientists get so like obsessed with it?
You know how you see a surprising result sometimes and you're like, could this just be a fluke?
Right.
Like, is this for real? The p-value, it helps you kind of put a number on that fluke factor. So in the simplest terms, a low p-value means it's really unlikely you'd get those results if there wasn't actually something real going on.
So like a tiny p-value means your findings are probably legit, not just some random blip in the data.
Exactly. And for a lot of scientific fields, that magic number for legit is .05. That's like your VIP entry to get your research paper published, to get funding, the whole shebang.
Which on the surface makes sense.
Right.
I mean, we want science to be rigorous. We want it to be based on solid evidence. But here's the thing that always trips me up. Why .05? Why not .04? Why not .06? It seems kind of random when you really think about it.
Oh, you've hit on such a huge point. And this is where things get really interesting because that seemingly random cutoff, it has a much bigger psychological effect than you might think. And that's exactly what Rao, Bai, and Varma, they wanted to get into. They weren't happy with, .05 just being this rule in a textbook. They wanted to know how it was actually like living and breathing in the minds of scientists.
So how do you even go about like measuring that? Did they like strap EEG headsets on a bunch of postdocs and start like flashing p-values at them?
Almost. I mean, not quite. But they did design some really clever experiments. One of them is called the AX experiment. So picture this. You're a grad student in psychology. You're staring at a computer screen. Pairs of p-values are flashing before your eyes. And all you have to do, your task, is simple. Are these p-values similar or are they different? Easy peasy, right?
Yeah, I mean, I'd like to think I could tell you if two numbers are pretty close together. So did our scientist participants, did they breeze through this? Did the .05 like even matter?
Well, here's where it gets really wild. So they found that when those p-values crossed that .05 line, the grad students reacted like a chasm had opened up between the numbers suddenly. They saw p-values like .049 and .051 as totally different like species, even though numerically they're practically the same.
Wait, so even though those numbers are like next door neighbors on the number line, that .05 border made them seem miles apart. That's kind of freaky.
It is kind of freaky, right? It's like our grad students, they've got this like X-ray vision that lets them see this invisible .05 barrier that the rest of us were totally blind to.
So is this like some weird thing about how scientists' brains work? Like maybe years of like staring at spreadsheets and like deciphering stats formulas has like, I don't know, rewired their neural circuits or something?
That is a great question, and that's what Rao, Bai, and Varma wanted to figure out. So to see if this was like a scientist thing or just a human thing, they brought in a control group, a bunch of, fresh-faced undergrads who hadn't been initiated into the world of p-values and peer review and all that.
Okay, so the undergrads are like our baseline then. So did they see the .05 chasm too? Or were they like cool as cucumbers, judging the numbers like normal people?
Well, get this. The undergrads, they didn't even flinch at that .05 mark. They just looked at the actual difference between the p-values and they called it like they saw it. No drama, no invisible fences, nothing.
Wait, so you're telling me the undergrads, who are totally new to this whole research game, were actually better at judging these numbers objectively than the seasoned grad students? That's kind of mind-blowing.
It is mind-blowing, right? And what it tells us is that this zero point zero 0.05 bias, it's not something we're born with. This is learned behavior. It's like years of stats courses and academic pressure, and seeing that zero point zero 0.05 cutoff everywhere you look, it's like it's subtly shaped how these grad students, how they actually perceive the very building blocks of data.
That's fascinating, but it's also a little bit like concerning, right? I mean, we want our scientists to be objective, not swayed by some arbitrary line in the statistical sand. It makes you wonder, like, what other subtle biases might be lurking beneath the surface of all this research?
Oh, absolutely. And that is exactly the rabbit hole that Rao, Bai, and Varma, they wanted to go down. They weren't content with just demonstrating this 0.05 bias, right? They wanted to see, did it actually have real-world implications? So they took it a step further with an even more ingenious experiment. This one's called the ABX test.
Okay, so first we've got AX, now we've got ABX. Is this like scientific alphabet soup, or are we actually getting somewhere with this?
Trust me, it's worth it. Okay, so think of the ABX test like this. Instead of just showing you two p-values, now we're throwing in a third one into the mix. And your job is to decide which of the first two p-values is most similar to that third one.
Okay, I think I'm following. Give me an example, though. Walk me through this.
All right, so let's say you see these three p-values, 0.043, 0.049, and 0.054. Now, just looking at the numbers, 0.049 is mathematically closer to 0.054.
Right.
But, and you can probably see where I'm going with this, but the grad student's 0.05 bias, well, it reared its ugly head again.
Don't tell me. Even though 0.049 and 0.054 were mathematically closer, they were blinded by that 0.05, and they grouped 0.049 with the other sub 0.05 p-value.
Bingo. It's like that 0.05 mark. It's like it creates this like perceptual distortion field where numbers on either side, they just seem further apart than they actually are.
This is wild. It's like we're hardwired to see these patterns even when they're not really there. But okay, let's be real for a second. This is all super interesting, but it does kind of raise some big questions, right? Like we have to address the elephant in the room here.
Go on.
Are we saying that grad students, these budding scientists, are like fudging their results because of this 0.05 bias? Are we saying that grad students, these budding scientists, are like fudging their results because of this 0.05 bias?
Whoa, hold on a sec. That's a big accusation, right? It's not necessarily about like intentional fudging. Remember, we're talking about like these subtle biases in how we perceive things, not outright manipulation. It's more like this 0.05 thing, it's like an optical illusion. You know what I mean? It's like it's making them see the data just a little bit off.
Okay, that's reassuring, I guess. But it still makes you wonder, right? Like, if something is as supposedly objective as numbers can be seen in such different ways, what other implications does that have for the whole research process?
Oh yeah, no, that's a totally valid concern, and that's why Rao, Bai, and Varma, they didn't stop there. They wanted to go deeper, asking like, could this 0.05 bias actually be linked to, well, they call them questionable research practices. QRPs is what the cool kids call them.
QRPs, okay. Sounds kind of ominous.
Yeah.
What are those? Fill me in.
So think of QRPs as like the gray areas of research. Stuff like peeking at your data before the experiment's really over, or, maybe tweaking your methods just a tiny bit to get a result that looks a little bit better. Or even like deciding to just gather more data, but only if your initial results are, close to that magic 0.05.
Okay, so not full-on fraud or anything, but definitely like pushing the limits ethically, right?
Exactly. Right on the edge there. So the million-dollar question was, are those grad students, the ones who were really hung up on that 0.05 in those AX and ABX tests, are they also more likely to think those QRPs are okay?
Right. All right. Hit me with it. Did our researchers find the smoking gun?
Well, this is where it gets interesting. Again, they didn't. There was absolutely no link. They found zero correlation between how strong that 0.05 bias was and people's attitudes about those QRPs.
Whoa. Really?
Yeah.
That's not what I was expecting. I mean, it just seems so obvious. Like if you're obsessed with that 0.05 cutoff, you'd be more likely to bend the rules a little to get there.
Oh, it does, doesn't it? It makes sense. It's a very human thing to think. And frankly, I was kind of surprised too. But here's the thing. This is actually huge. If this bias is so deeply ingrained, but it doesn't actually lead to like bad behavior, what does that tell us?
Okay, I'm listening. I'm hooked. What are we thinking here?
Well, for one thing, it could mean that even though this 0.05 bias can like sneak its way into how we see data, it doesn't totally control us, right? It doesn't override like our understanding of what's right and wrong ethically when it comes to research.
So it is possible to know about this bias, to see it and still make good choices, even when it feels like the numbers themselves are trying to trick you.
Yeah, absolutely. And maybe the whole scientific process itself, right? With peer review and having to replicate studies and sharing data openly, all that stuff, maybe that actually helps to keep this bias in check, even if we don't always realize it's happening.
Okay, that's kind of reassuring, to be
Yeah.
honest. It means those safeguards we've got, they're actually doing their job.
Yeah, for sure. But it also shows just how important it is to be aware of these things, these subtle biases that are kind of working behind the scenes, right?
Yeah.
Influencing our choices in ways we don't always see. It's a good reminder for everyone, not just scientists, to really think critically about the numbers we use every single day.
So what you're saying is the 0.05 p-value, it's like the tip of the iceberg when it comes to these hidden forces shaping our thinking.
Yeah.
It makes you wonder what other biases are out there, right? Quietly shaping how we see the world every day.
Exactly. And honestly, it's a really exciting area of research. And the more we understand these hidden patterns in our thinking, the better equipped we'll be to make really good decisions that are objective and informed.
Well, on that note, I think it's time to wrap up our deep dive into the world of p-values and perception and all the fascinating, strange ways our minds work. Thanks for joining us here on The Deep Dive. We will be back next time with another deep dive into a topic that's sure to get you thinking differently about the world. Until then, stay curious.